So welcome to this segment as we look at S6 in the 2024 50/70, chemistry paper 2. It says the reaction magnesium plus hydrochloric acid to produce magnesium chloride and hydrogen is both displacement and redox. So they say justify why the reaction is displacement. Now remember, displacement is a type of reaction where a more reactive metal displaces a less reactive substance from its compound. In this case, if you notice, magnesium is replacing the hydrogen ion or pushing out the hydrogen ion from the acid to become magnesium oxide. So why are we saying that it is displacement? I could simply say because magnesium displaces. So we can say because magnesium displaces hydrogen from the acid. So that is why we are simply saying that that is a displacement. Then what about, why can we say that such a reaction is actually a redox reaction? Now there are two aspects. When we talk about the redox reaction, it's a combination of two things: reduction and oxidation must be taking place. So if you look at it this way, if you write the half reactions that are happening there, when you separate them, you are going to see two things that are happening there. You have magnesium, which produces magnesium ion and it is going to lose 2 electrons. Then on the other hand, what is happening is that the hydrogen ions are now becoming hydrogen gas. When we balanced up that and they gain 2 electrons. So you can see in terms of the magnesium, it is actually oxidized. Yeah, remember when we talk about oxidation, if you still remember if you still remember that oxidation is loss of electron, but reduction is simply gain. So that is what is happening. So magnesium is losing electron to become magnesium ion. So it is oxidized. Then in terms of, if you write your ionic equation, hydrogen ions are becoming hydrogen gas because they are gaining electrons, and therefore we simply say that it has actually been reduced. Now, because oxidation and reduction is taking place, it simply means that it's a redox reaction. So we can simply say that it is a redox because magnesium, so I can just say magnesium is oxidized while hydrogen ions are reduced. So that's the idea. So because magnesium oxide is oxidized and hydrogen gas is reduced, no wonder we are saying a redox reaction is taking place. So I just want to pick up something in my rule so that we can do the next question. So remember, a redox reaction, a reaction in which both oxidation and reduction occur simultaneously. So that's what you needed to do. You can pause the video and go through that, or you can visit my other videos so that you can learn. According to this question there, it says, during the reaction, Elena discovered that the temperature of the surrounding, so the temperature of the surrounding increased. Draw a well-labeled diagram, draw a well-labeled diagram, a labeled energy level diagram for the reaction showing the enthalpy and the activation energy. The axes have been drawn for you. Now it should be a well-labeled diagram. Now because it says the temperature of the surrounding increased, if the temperature of the surrounding increased, it simply means that this is an exothermic reaction, meaning heat energy was actually given out. That's the key to answering this question. So in an exothermic reaction, the energy of the reactant is greater than the energy of the product. So therefore, when you're drawing, that's why I went to pick up my rule there. So in terms of the axis, we need to label them. I can simply say, progress of reaction. Then this side we can actually have energy, whether the energy is in kilojoules per mole or joules per mole, but there should be energy. So these are supposed to be labeled, very important. Now, since the energy of the reactant is greater than the energy of the product, it simply means that, the product are supposed to be I'm supposed to have the reactants are supposed to be at a high level. Then I'm going to have, the products right, somewhere, there. All right. Then you're going to draw, a hue starting from there, ending all the way up to there. Okay, so that's what you're going to do there. So this is what you needed to do. Then this is representing the reactor, the reactants, and here you are going to have the products. On top there, that is what we call as being the transition state. So you need to draw an arrow from the reactants to the highest point or to the transition state. So your arrow should be pointing like that, and that is representing the activation energy. On the other hand, from the reactant to the product, you draw an arrow going in a single direction, not two arrows, just an arrow going down. This is representing the enthalpy change, and the enthalpy change is simply going to be negative because this is simply an exothermic reaction. So they wanted you to label the enthalpy change and the activation energy, but you also needed to label the axis. So this is exactly what you needed to do in this reaction. Hopefully you got to understand how this is actually done. Sometimes they can even ask you to describe an exothermic reaction, so you should be in a position to do that. Thank you so much for watching. In my next video we'll look at A7. This is under electrolysis. Stay tuned please for the next video.